Okay, hello. Welcome to Geometry in Action. We're going to investigate rotations around the origin. And discovering a rule. So, a rule for rotations would be a rule that we can use with any set of points, or any point or any set of points, to determine what the image will be. Now, we're gonna look at clockwise rotations around the origin, and we're going to consider these different degrees of rotation. So the pre-image, without moving at all, that would be 0 degrees. Then a 90-degree rotation, 180 degrees, 270 degrees, and 360 degrees. So one thing I want you to notice, of course, is that I picked these numbers so that it'll be a little bit easier. And they're also, these are the common numbers people use for rotations. It's much easier than rotating different, degree angles like 60 and 30 and 42 degrees. But I want you to notice that a 90 degree, all of these are multiples of 90. So 90, of course, is just 90. 180 is 90 plus 90. 270 plus 3 90s, 90 plus 90 plus 90. 360 is 4 90s. 4 times 90, or 90 plus 90 plus 90 plus 90. Now remember a couple of things. One, clockwise, which is the one we're going to be talking about today, is a circular motion around to the right. Counterclockwise, counter is against, so it would go the opposite direction. So it would be a circular motion around to the left. That's counterclockwise. Clockwise, circular around the right. So we're going to investigate clockwise rotations, but you could do the exact same thing that we're about to do by rotating counterclockwise. So we're going to use, this will be on coordinate plane. I'm going to start with this point right here. I'm going to call it point A, and this point is 2, 5. And we're going to use our magic Ziploc bag. And move this here. That's our magic Ziploc bag. And I've designed this so that these orange lines line up perfectly, or pretty close to perfectly, with the axes. These orange lines, or line segments more accurately, are going to guide me in rotating 90 degrees, because as you know, a square angle like this is 90 degrees. So 90 degrees angle here, all 4 of these angles would be 90 degrees. So we're going to use that to help us help us rotate 90 degrees. So when I turn this, so that when this line right here lines up perfectly with this one, I'll know I've rotated it 90 degrees. The other way you'll be able to tell is I drew a line segment from this point to the origin, here and here. So I'm going to show you, we can look at this and tell when we've gone by a 90 degree rotation by looking at, there should be a 90 degree angle between these two lines. So if I only rotated a small amount, well, let's make it like this. I rotated a small amount, the angle between these is not 90 degrees, as you can see. So it hasn't been rotated 90 degrees. Not only that, this line right here is not on top of that. So there's 2 ways we can see the 90 degree rotation. So that's what we're going to start with, and I'm going to try to keep this as still as possible, make that rotation. So we're going to rotate that around. When the orange line is on top of the x-axis, that should be a 90 degree angle. Now notice this line segment that goes from this point to the origin, and then this one, the red line segment, they form a 90 degree angle. And that's also at the same time that this right here, these 2 line segments, or 2, form a 90 degree angle as well. So I rotated it 90 degrees. So now, what is that new point? Because that's going to be the whole point of this. We're going to start off with 0 degrees, which is our pre-image. And at 0 degrees, our first point was 2, 5. And we're going to do 90 degrees, and that was this first turn here. So now our new point, we're going to call it A prime, not A, but A prime. So this is the image of that one. And that point, I'm just going to get it from here, is 5, negative 2. So 5, negative 2. So we've got it went from here to here. So this is the image of this point after a 90-degree turn. And I want you looking for patterns in this, because this is how we're going to figure out what the rules are, is to look at the pattern. And so as we go from point to point, from 90-degree turn to 90-degree turn, after 90 degrees it'll be 180, I want you to see how it's changing. So along with how it's changing, you should be trying to look at and see how it stays the same too. So what is the same about these two? What is different? Now, we have a 2 and a 5. If you ignore the signs, so we look at just the absolute value, we have a 5 and a 2. So a 2, 5, and we have a 5 and a 2. So we have the same numbers, but they're in different order, right? That's one thing. We also have different signs. So here, these are both positive. This one is positive, one is negative. So you should be looking at that, and the more that you can notice about it being the same and different, the easier it is going to be to find that pattern. So I'm looking at this, and I say, okay, 5 and 5 are exactly the same. So I'm going to draw a little arrow going from here to here, because this indicates that it moved. And I'm going to use black to indicate that it didn't change sign. However, this one, not only did it move, so I'm going to draw an arrow, but it changed signs. Right? It went from positive to negative. Since it changed, I'm going to put an arrow there. So that's something I want to keep track of, that change. Okay. Now, the next point, we can find that one by doing the exact same thing we just did. Now remember, 90 degrees, that was just one 90-degree turn. 180 is two 90-degree turns. So we already did the first. That was this one. So all we have to do is do one more turn, and that'll be 180. So there's 180 right there. Now notice something else. This is a straight line, right? Okay. Straight line segment. So that's what's called a straight angle. Okay. So this angle is forming is 180 degrees. So what do we have? Now this is from this point. Actually, it's from this point, which is also from this point, but this was the first one. We can't call it A prime because we'll get them mixed up. So we want to be able to keep track of them differently. So we want to use the same letter because they all came from the same point originally, but this is not the first one. We want to be able to tell them apart. Now the point is -2, -5. So down here, that's what we write, -2, -5. So just like we did on the one above it, you want to see what are the differences, what are the similarities, how are they the same, how are they different. Now we're still using 2s and 5s, right? -2 and -5, but it's still, the absolute value is 2. So we will go 2, 5, 5, 2, 2, 5. So hopefully you're starting to see something there, and maybe some thoughts are going in through your mind about what you might expect for the next row down. But for now, let's kind of focus on this. So is this one exactly the same as that one? So we have 5 and -5. So it changed locations, but it's not the same anymore, right? It was a 5, now it's a -5. So I'm going to use my red pen to indicate that it changed. Okay. then these two right here, okay, well, it changed locations, right? -2 went from the y coordinate to the x coordinate. But is it exactly the same number? It is, right? So now we got -2, -5, right? This one didn't change, the number didn't change, it just changed location. This one changed location and it changed sign, okay? So now you want to start looking at, everything you can to try to guess what's going to come next. So make a guess, write it down on your paper, just somewhere next to you, and see if you can guess this one. Because that's a very important step. You want to, once you start to think you know what it might be, you make a guess. But what's really important is you don't just make that guess. After you make the guess, you have to test it. So we're going to make our hypothesis. That's really what that is. It's a hypothesis, right? We make that hypothesis, and then we test our hypothesis to see if it's actually true. And even if you get it wrong, even if you're not right about that, don't get upset and frustrated, because sometimes you can learn more from a wrong answer than you can from a right answer. So, but either way, it can benefit you. If it was the right answer, then you're probably getting close, if not completely all the way to the correct answer. And if it's wrong, then you have to adjust things and you have to look at what is different. So here we have -5, 2, and we have to name it. So we already have a prime, a double prime. So we're going to use, instead of 1 or 2, we're going to use 3. So this is a triple prime, a 3 prime. Okay? -5, 2, that's our point. Okay? So what changed? What didn't change? Again, just like all of them, we have them crisscrossing, right? So this -5 went to this -5. Since it's the same, I'm going to draw my arrow in black. Then we went -2, that changed, didn't it? Now it's not just that it's changing, but how is it changing? And you want to see if you can see something that's the same, if you could say it in words, or if you can, figure out exactly what that means. It's not always changing to a positive. It's not always changing to a negative. It's changing from whatever it was, right? So if it starts out as a positive, it ends up as negative. If it starts out as a negative, it ends with a positive, okay? It's kind of like a power button, so that power button looks like kind of like that on your computer, okay? If the light's not on and you push it, it turns it on, right? Okay, let's say your light isn't working and your computer's on, and then you push it and hold it, okay, it'll turn it off. So whatever it is, it just changes from on to off, on to off. So it doesn't always turn it on. It only turns it on if the power is already off. But if the power is already on, it turns it off. And so that's what's going on here. It just changes it. So we have this. And then the next one, by now we should be able to make a guess, right? And be pretty sure that we're going to get it right. Now, you can use visual patterns as well, right? So if you look at this, that's all I did here. I used a visual pattern. So make a guess on what you think will come next for 360. Okay, 360 degrees. We'll go up here and look where it ends up. Right where we started at 2, 5. So this 2 doesn't change, it stays at 2. This -5 turns into a +5, and we end up with the same thing we started. Okay, which makes sense, I hope, because 360 degrees is a turn all the way to where you were, right? So if you play basketball and dunk the ball, or if you're a skater, you know what 360 means, right? So those aren't the only people that know what 360 means, of course. So that's how you can work out what the numbers will be, what each of the coordinates will be for each point on the image. Now, once you've done that, what happens if we have another point? Let's say 4, 2. And we'll call that B. What if we want to find out what is B prime after a 90-degree rotation? Okay. Now we can use what we just did to figure that out on this one as well, right? So we can go 2, 5. That went to 5, -2. So if we use this number right here, 4, 2, okay, then perhaps that'll do the same thing. All right? And we should have 2, -4. Well, let's see what happens. Okay. Does it look like it worked? That's 2, -4. That's what we needed down here, right? So yeah, that works. Okay. Now we can do the same exact thing and figure it out for every value. Now, x could represent for any value that we use for the x coordinate. Y represents any number we want. So we would do the exact same thing. And so what do? The y value goes unchanged. The x value moves and changes to negative. So this right here is our rule. But we're not going to write it like that, because that's not the accepted way that people write it. So the way we're going to write it is like this. So this is our pre-image. And we're going to draw an arrow. So instead of drawing both of these arrows here, we just draw one arrow, and we write the pre-image. The image. And that'll be y -x. So basically what this is showing is whatever number that goes here gets placed second in the y coordinate, but we have to change the sign. This one, we switch it, and we keep it. We keep the sign. So the way you would work that would be, let's say we want to rotate -5, 6, 90 degrees clockwise. Okay, so we're going to use this same rule, because this rule should work with any number. But instead of x and y, we're going to use -5 and 6. Now here we're going to put our y, and here we're going to put -x. Now I'm going to have to put the negative no matter what, so I'm going to put this down here, and then I'm just going to put x right in here. So the negative goes out here and x go in here. So the first thing you want to do is you want to look and ask yourself, what's x? It's -5, right? And what's y? 6. All you do now is put them in their place. So y is 6, so it goes here. X is -5, it goes here. Now we want to simplify this, and this one's already simplified. So we have 6, comma, -5. When we have two negatives like this is like saying the opposite of -5. What's the opposite of -5? Well, it's +5. You don't need the plus sign. You can use it if you want. So this would be your new point. This would be the image. So you just take this format right here. This is our rule, and you plug it in. Okay. You can find any other rule for 180, 270, or 360. If it's only 90, then you could probably do this if you wanted to every time. You want to carry a Ziploc bag around, and then just do that every time, that's fine. But sometimes it can be helpful to have the rules written down, but we have to figure them out first. So for 180, what that will look like is we do the same exact thing. What happened? We went from the pre-image, which was 2.5. We're going to use the same one. And then 180 is this one here. So it went from 2.5 to -2, -5. So now notice this time they didn't go, so 5 went straight down, 2 went straight down. But both of them, when they went straight down, they changed the signs. So what we're going to do on this one, we're still going to start off the same. That's the pre-image, same as before. The second one is the image, right? So that's our pre-image. This will be the image. And how did it change? It started with X and Y and ended up with -X and -Y. So that would be the rule for 180 degrees. Clockwise. Okay? Now if we wanted to do 270, you could do it the same way. You would do 2.5. How did it end up there? -5, 2. So what happened here? That one changed. That one didn't. So XY. Okay, so it changed locations on both of them. So we need a Y and an X. And then this one changed from positive to negative. So this would be your rule for 180 degrees.